Math 3, Spiral Review, Radical Equations. Solve each equation. Remember to check for extraneous solutions. I'm going to do numbers 1, 2, and 7 all the way through. And then the other questions, I'll make sure that we at least isolate the radical so that you at least have the beginning part correct. And then you can just check your answers on the key that I will post later. So the whole goal with radical equations is that you need to isolate the radical first before you try to cancel out the radical. So on number 1, you have to get rid of this -5 that's being multiplied in the front. So to undo multiplication, you have to do division. Divide by -5, because whatever you do on one side of the equation, you have to do on the other side of the equation to keep it balanced. So square root 9 minus a equals 1. Now that the radical is all by itself, to undo a square root, you have to raise it up to the second power. You have to square it. Whatever you do to one side of the equation, you have to do to the other side. Now keep in mind, whatever the index is, index means, if I go off to the side here, like the 3, that's the index. So if you have a third root, you raise it up to the third power to cancel out. If you have a 7th root like that, you raise it up to the 7th power to cancel it out. So I think, let me glance, I'm pretty sure all the ones on here, yeah, these are all square roots, so we're just going to square everything. But if you did have different indices, so the 3, the 7, you would raise it up to that power to cancel out that index. Back on the problem we were working on, the square root and the square cancel each other out. So you're left with 9 minus a equals 1, because 1 squared is just 1. And then we want to solve like normal. So -9 minus 9, we get -a equals -8. Divide by -1, divide by -1, and a equals 8. Now with radical equations, it's really important that you check your answers to make sure they actually work, because sometimes we get extraneous solutions that don't work and we have to throw out those answers. So then off to the side here, I have to check my answer. And in order to check, you simply take your answer, plug it back into the original equation, simplify, and see if you end up getting a true statement. So in this problem, I take my a value of 8, and I plug it in for a like that. And then don't think of it as solving, just think of it as simplifying. So on the left side, 9 minus 8 is 1, square root of 1 is 1, -5 times 1 is -5, and yes, that does equal -5. That works, so yes, a equals 8 is an answer. Let's go over to number 2. So on number 2, the part that we're trying to isolate, I'm boxing up right here in green, we have to get the square root all by itself. So to undo addition, I'm going to subtract 2 from both sides of the equation. So then I'm getting square root of x over 9 equals 0, because 2 minus 2 is 0. And then now that the radical is isolated, in order to undo a square root, we want to square both sides. So then we're left with x over 9 equals 0. In order to undo division, we're going to multiply. Whatever we do to one side of the equation, we have to do to the other side. So x equals 0. And again, super, super important. You have to check, because you might not actually have your answer as an answer. It might be an extraneous solution that you have to throw out. So when I check, I take my answer of 0, I plug it in wherever I see x, and then I just simplify and see if this actually works. So 0 divided by 9 is 0. The square root of 0 is 0. 2 plus 0 is 2. So yes, 2 does equal 2, meaning x equals 0 is an answer to our radical equation. On 3 and 4, let's just make sure you have the initial start correct, and then you could check the key later for the rest of the work. So on number 3, I'm going to box up the radical that we need to isolate all by itself first. So in order to get rid of this negative 10, I have to add 10 to both sides of the equation like that. So square root negative 8 minus 2v equals 0. And then you would solve from there. On number 4, let's box up the radical that we're trying to isolate. So I have to get rid of that positive 9, so I have to subtract 9 from both sides of the equation. So square root x plus 7 equals 9, and then you would solve from there. On 5, when you look at the right side of the equation, the radical is already isolated, so you're actually ready to just jump into squaring both sides of the equation to solve that one. Same thing on 6. The square root's already all by itself on one side of the equal sign, so you're ready to just jump into solving the whole equation by squaring both sides. On 7, the square root is already isolated, and then I want to actually go ahead and do this one all the way through. So I am going to change colors. I'm going to square both sides of the equation. So squaring a square root, everything cancels out, so I'm just left with 2r plus 7. And then the reason I wanted to do this one is because when you square r minus 4, you have to do r minus 4 times r minus 4 and then multiply it out. So that's why I want to do this one together. So first times first, r times r is r squared. Outside times outside, r times negative 4 is negative 4r. Inside times inside is negative 4r. And then last times last is negative 4 times negative 4, which is positive 16. And then from here, just keep proceeding like normal. So I'm going to add my like terms on the right side of the equation. So I have negative 4r minus 4r is negative 8r. And then since I have r terms and an r squared term, I want to get everything on one side and set it equal to 0 so that I can factor. So I'm going to subtract 2r from both sides, and I'm going to subtract 7 from both sides. That way I get everything on one side. So r squared minus 10r plus 9. Now, if you get down to one of these and you cannot factor, you would just use quadratic formula. We're usually pretty nice and give you problems that can factor. So let's see. This is a basic trinomial because the number in front of the r squared is an invisible 1. So we're looking for two numbers that multiply to 9 and then add to negative 10. So I think that should be negative 9 and negative 1. So yes, negative 9 times negative 1 is positive 9. Negative 9 plus negative 1 is negative 10. So now we want to set each factor equal to 0 and solve for r. So we're getting 9 as one answer and 1 as our other answer. Now let's not forget the all-important check step. So off to the side here, I'm going to check my answers. And you have to check each answer separately. So I'm going to do, it's going to get a little tight on space here. I'm going to do 2 times 9 plus, actually, you know what? I'm just going to check it down here instead of squishing everything. So square root of 2 times 9 plus 7 equals 9 minus 4. And again, when you're checking, you're not actually solving anything. Just simplify the left side, simplify the right side, and then see if they end up equaling each other or not. So square root of 25, and yes, 5 does equal 5. So yes, r equals 9 does work. Now let's check the other solution, the r equals 1. So square root of 2 times 1 plus 7 equals 1 minus 4. So 2 times 1 is 2. 1 minus 4 is negative 3. 2 plus 7 is 9. Square root of 9 is 3. 3 does not equal negative 3. So we have to cross without x equals 1, it is not an answer. It's an extraneous solution. Looking at number 8, let's just make sure you have the right start. So I'm boxing up the radical. That part in green has to be all by itself on one side of the equal sign. So there's that extra 3 in the front. So to get rid of that 3, I want to subtract 3 from both sides. So square root of 6a minus 18 equals a minus 3. And then now you would just square both sides and go from there. 8 should be very similar to 7 from this point on. In order to see the problems that we only started, just check the key that I will post on Canvas to get those problems.